So we want to have a look now at using the coefficients of polynomials to solve some problems, and we're going to use the coefficients and the roots of the polynomials to do that. So this is what you need to be able to do using this, and it might not mean much at the moment, but hopefully by the end of the videos here that you'll understand exactly what we're going to do with all these ones we're going to be doing together. But what we want to do is write down the roots, relationships and roots of the coefficients, polynomial equation degrees 2, 3, 4. Now we've done a lot of this. This is stuff we've done in extension 1, but what we're going to do is take it a little bit further. So from extension 1, we've seen these tables. We know these rules. We've done work with that in extension 1, and we've done one with a quartic equation, roots of alpha, beta, gamma, delta. So we've done work with some of that. So we know those rules. So how do we start to put them into play and start using them? So what we want to do to expand something like this, like it's a bit painful to try and expand and keep multiplying the brackets out and everything. Let's try and think of a different way to do it. We know it's monic, so we know our polynomial is going to be in this form, and a would be equal to 1, and we know our roots are 1, minus 2, 3, and 1. So we can go about it by saying, well, we know that the sum of the roots one at a time, add them up, is 1. So minus b on a is equal to the 1 here, so minus b is equal to 1, so b is equal to minus 1. And then we can keep going the same way. Sum of the roots 2 at a time gives us the c. Sum of the roots 3 at a time gives us the d. Sum of the two roots 4 at a time, or the product of the roots, gives us the e value. So just by doing those calculations allows us to write our polynomial in that form, because we found a, b, c, d, and e. So it's just a way of using those roots to help us solve some problems. So this time we've got alpha, beta, gamma as the roots of that. How can we use that to work out alpha squared plus beta squared plus gamma squared? Well, again, we know that the idea that we've got to go back to the sum of the roots 1 at a time, 2 at a time, 3 at a time. So we go and solve those. Do those first. And then we use the idea that we know that when we have these squared, then if we have the sum of the product, sum of the roots all squared, minus 2 lots of alpha, gamma, beta, gamma, works back to give us that. Now, if you're not sure that that's true, if you don't trust me, expand this out. I'm sure you trust me. Sure you do. But you can expand that out, and you can see that that's what it will give us, because these are the terms that get doubled up in there, and so we subtract them away. But notice we've gone back to some of the roots 1 at a time, some of the roots 2 at a time. We're able to put these values in and be able to get us a value for that alpha squared plus beta squared plus gamma squared. Alpha cubed plus beta cubed plus gamma cubed. Then we're looking at a little technique here to do this one. So if we have a look here, take our polynomial that we've got. We know it's going to be equal to 0. So if we write x cubed is equal to 2x squared plus 3x minus 1. So all we've done is just taken everything and put it on the right hand side. So we're just manipulating it there. Now, if alpha is a root, then we can substitute alpha into that expression. We could substitute beta into that expression. We can substitute gamma into that expression, because alpha, beta, and gamma are roots. So we can substitute it in, and they hold. Now, have a look when we do this. Sum your left-hand side is alpha cubed plus beta cubed plus gamma cubed. So if we do that, that must be equal to the sum of the right-hand side all squared. So that's what we've done there. We've taken everything on the right-hand side and added it together. So there's the little trick in this one. The alpha cubed plus beta cubed plus gamma cubed is equal to this expression here, which we can start to collect in 2 lots of alpha squared, beta squared, gamma squared, 3 lots of alpha plus beta plus gamma minus 3. Now from part A, we know the value of that was 10. We know the sum of the roots 1 at a time was 2, and we've got the 3 at the end. It was our minus 1 minus 1 minus 1 gives us a minus 3. And we can do that calculation to give us 23. So there's the trick to do all that, do that type of question. Some of the squares is okay, but what about some of the cubes? That's how we get around that. And the same thing for alpha to the power of 8, alpha to the power of 4, beta to the power of 4, and gamma to the power of 4. Again, take what we did in the last question, and then multiply both sides by x. And we can start manipulating. We put alpha, beta, and gamma in, and sum those, like we did in part B. But this time we're going to sum our right-hand side. So put alpha in, put beta into that expression, put gamma into that expression. And we've got an expression that we can start to manipulate and collect our terms. So we get to alpha cubed, beta cubed, gamma cubed, which we just found the value of in part B. Alpha squared, beta squared, gamma squared. We can put that, we've found the value of that before, and the sum of the roots one at a time, because it's a -2, and we're able to do that calculation. So there's a little trick to handle these types of questions. So when you're looking at what you need to do, we need to do that manipulation. Question 3, this time we've got alpha, beta, gamma are the roots. So again, of that equation, so what do we get when we get 1 on alpha, 1 on beta, 1 on gamma? We've got to get the addition of it. So again, like we've done before, we get a common denominator and get our relative numerators there. Again, work out your sum of the roots 1 at a time, 2 at a time, and 3 at a time, and you're able to substitute those and put them in. If we've got alpha to the power of 5, beta to the power of 5, and gamma to the power of 5, well again, if we look at our equation, we can write x cubed equal to 5x plus 1. And like we did in the last question, we can just multiply by x squared and then sum our left hand side and sum our right hand side. So we can break down the alpha cubed plus beta cubed plus gamma cubed, because we've got alpha cubed would be 5 alpha plus 1. So we can see that one's going to be equal to that part from this part here. So 5 beta plus 1, 5 gamma plus 1. So you can keep breaking it down till you work back to sum of the roots 1 at a time there, and the product sum of the roots 2 at a time. You're able to put the values in that we found here and put them straight into the equation, put them into in there, and we're able to simplify it down to that one. So there's a couple of little tricks that you can look to find. This time, here's another trick of working on this one: alpha plus beta minus gamma. So the idea here, if we looked at this one and worked out, well, alpha plus beta plus gamma minus 2 gamma would give us a minus gamma. But notice we're working back to get the idea that we've got the sum of the roots 1 at a time. So when we've got that, it nicely happens that it works out on all 3 of them. So there's a little technique to play around with there. But gives us, we know from what we've got in part A that we worked out that the sum of the roots 1 at a time was 0. Gives us a -8 alpha beta gamma, which, well, there's the product of the roots. We can sub that in, and we're able to simplify to give us a -8. So a few little techniques we've found doing those questions. There. Let's have a look at this one. We've got 2 roots are reciprocals, while the 2 remaining are opposites. Find the roots to find C and D. So if that's the case, our 2 reciprocals, alpha and 1 on alpha, and the remaining 2 are opposites, so beta and minus beta. So there's the roots we want to get. So what happens? Let's work out our sum of the roots 1 at a time. Well, the betas are going to cancel. Gives us alpha plus 1, and alpha's 5 on 2 because minus b on a. And so we're able to get a quadratic, and we start to work it out that we've got alpha simplifying down to a half or 2. Well, there's the reciprocal, so it doesn't matter which one you take as alpha. The other one's going to be the reciprocal there. So there's your 2 values there. So there's 2 of the roots. And then if we multiply them and we get the alpha and 1 on alpha cancelling, beta times minus beta, that would be equal to the minus d on a. So we get minus beta squared minus 9. So we're able to get to there. So we've had the minus 18 there. Sorry, I said D, it should have been E on A. So we've simplified it down. Beta squared is equal to 9, or beta would be plus or minus 3. Same value, but opposite in signs. So what we can do then is look to go, we'll find the sum of the roots 2 at a time, would be C on 2. So we put that in, do our values from what we've got with the alpha and 1 on alpha, beta and minus beta. And we go through and we can do that, do all those multiplications to get down to C as minus 16. And then we can do the sum of the roots 3 at a time, which is minus d on 2. So again, minus d on 2 would equal all those, do the sum of the roots 3 at a time, do all those multiplications. We get those values, add them together, and we get d is equal to 45. So there's our equation that we're going to have. So we're able to play around, and we're able to do that and get our values there just by manipulating the roots of the equation and being able to being able to use our ideas about roots and being able to do some algebra with them.